Okay, this is a video for 4.1, which isn't in our notes package because the old notes for this used to use TI graphing calculators. You know, one of these bad boys here. And if you have one of these calculators, I'd be more than happy to show you how to use it to graph things. In fact, maybe I'll do one example using the calculator. But the superior technology, and since we're only really going to use graphing calculator technology for just 4.1, when we hit chapters 4.2, 4.3, 4.4, we're back to paper and pencil and regular calculators and our magnificent brains. Since we only need it for like one assignment, we're just going to use the technology on the computer. We're going to use Desmos. Desmos is www.desmos.com. Just Google the word Desmos and open their graphing calculator, and boom, there's your calculator. So let's take a look at a couple of examples from the textbook. So let's see, where's that textbook file? Oh, textbook file, textbook file. Okay, so as we talked about in chapter 3, any object that is thrown, flung, launched under gravity makes a parabola. Even a bullet out of a gun is making a parabola. It'd just be a really wide one. So gravity wins every fight. Everything's going to get to the ground eventually. There's the graph for the water fountain in the picture, and as you can see, it's a parabola. They even have an equation for it. Isn't that nice? -6 times x minus 1 plus 6. Now, in the real world, it is so not very often that you're going to get a lovely parabola with an equation with nice integers for a, b, and c. So I'm going to jump right to, now again, they say that, hey, if you don't have a graphing calculator, make a great big table of values and graph 40 points and enjoy making that parabola. We're not going to do that either because we've done chapter 3. We know the shortcuts for making this graph. We can find its vertex, its intercepts, and then just sketch. We would not spend our time doing that. Have fun if you want. Not me, not this guy. It is cool if you know how to use Excel, and spreadsheets can make graphs of parabolas too. But again, it requires entering all this data, which is only a little less work than doing it by hand anyway. So Excel's not our friend either. We're going to use graphing technology. So if I wanted to graph the equation, let's start with this nice easy one. What is it again? -x squared plus 8x minus 16. So I'm going to, I'll use the graphing calculator first. First of all, you have to make sure, let me just quit that. You have to make sure that the window that you have it set at is what you're going to see. So let's start the window. That's the default setting. We're looking at a grid that goes from -10 to 10 on the x-axis with a scale of counting by ones. And it goes from -10 to 10 on the y-axis with a scale of counting by ones. My one person in the room who's playing with or two, sorry, there's two people in the room playing with a graphing calculator. Even though yours isn't the same brand, it probably works just like this. And now let's enter the equation. What was it again? That's how good my memory is. Oh yeah, it was -x squared, right. So -x squared plus 8x minus 16, and then hit graph, and there it is. There's my parabola. Let's see, let's compare it. Does it look like the one they drew? It certainly does. And then, when you want to know what the x-intercept is, you can go to second function, calculate. See how calc is this little yellow up there? And what do we want to calculate? What do we call x-intercepts again? It's number 2. Click on number 2. Now, it's gonna there's possibly more than one x-intercept. So it's going to give you a range of numbers to look for that x-intercept between. It is somewhere between x is 0, enter, and okay, we're going to have to go past that intercept so it can find it. So just toggle to the right, there it is, go past it. Oops, oh, I just clicked badly. Go past it. There we go. I'm definitely past it, and then hit enter. And then it's going to, it says guess, ignore that, hit enter again. That's like an estimate it's giving you. In case it's like, you sure you want me to calculate this? I could guess for you. No. Hit enter again, it'll calculate, and there it is. Now, the graphing calculator isn't perfect. We actually know just by looking at it that that thing factors, and x is going to actually equal 4. But it comes really, really close to 4, and it doesn't quite get there. How come? Because it's counting pixels, right? And the pixel didn't quite exactly hit at 4 as it was counting, but feel free to just round that. You know that it's 4. Look at that. The graphing calculator is actually a weaker technology than your brain. You could have factored this and set it to 0 probably in your head, because it's a perfect square trinomial, right? 16 is 4 squared. Now let's try the same thing on Desmos, and you'll see this is a better technology. Why do they keep making people buy those calculators? Because, again, think about it, like things like AP exams and stuff, they don't want you having your phone or a computer that you could communicate with other people. The TI calculators don't have that ability, right? So that's why they, plus all of their textbooks are written for the TI calculator, and they're not changing that anytime soon. So that's why the TI still is around. But as you can see, check this out. Why? Oh, hang on. Oops. Oh, man. Technical issues continue. Every time I touch something, it's not what I want. There we go. Y equals. And what was it again? It was negative x squared. Was it minus 8 or plus 8? Plus 8, thank you. Plus 8x. And then it was plus 16? It was negative 16. Thank you. Minus 16. And there it is. Boom. And look at how nice they are. They actually, all you got to do is move your cursor over and it tells you the vertex. You don't have to do that trace stuff and let it try to count pixels for you. I mean, this thing actually is counting pixels too, but it's a heck of a lot more powerful than the handheld calculator, so it can count literally millions of them, right? So there you go. So there it is. That's the technology we want you to use. Let's try a tougher question. Obviously, I wouldn't use that technology on something that I could factor very easily. So let's get to one that's a little more real world. Even that one I could factor. So forget that second example. Is there one and is there a third example? How about, the curve of a suspension bridge has this equation. H of D is equal to 0.0025, open a bracket, D minus 100 squared minus 10. I would like to know the distance between the two towers, so I want the distance between the two X-intercepts. So I need the X-intercepts. This one we could set Y to 0 and solve for D. We'd get 2 answers, but we can use our technology to do it for us. So I won't bother with the graphing calculator. I'll just go right to Desmos for this one. So back to Desmos and erase that one. And by the way, you can change what variable you're in. And you can also type it in function notation. You can literally type it exactly the way they do in the textbook or in a physics textbook, and it'll understand. It'll understand what H of D is. Oh, actually, no, it won't. How about H of X? There we go. So there, the function of X is, and let's see, what was my textbook? Actually, I can set the D with a slider, but I don't want to mess with sliders right now. Try to keep things simple. So I'm just going to use X instead of D. So 0.0025. So I'm going to go and I'm going to punch 0.0025 and then open a bracket, and then it was X, and was it minus 100 or plus 100? Thank you. Minus 100 squared. How do you get to squared? Oh, well, hang on a sec. Get on the other side of this bracket first. Maybe end the bracket. How about that? How do you get squared? Well, I can type it on a keyboard as Shift 6, and now I'm in squared mode, right? Boom. If you don't have a keyboard, if you're using your phone, you click down here, and it's one of the first things that'll come up. Hit A squared, and boom, there you go. You're squaring it. And what was the constant again? Minus 10, thank you. So minus 10, and then graph. Now, I guess I should give props where credit's due. Hey, where's my graph? On a graphing calculator, some people already know what's going on here. It's like, it didn't. There's probably people going, it didn't graph it. Something's wrong. No, it graphed it. But notice in our scale, we can't see it. We're not looking at the right place on the grid. Credit where credit's due. A graphing calculator, you hit zoom 9. There's a zoom button. It's right here. Zoom. Hit zoom 9, and it figures out where to show you the grid so you can see the graph. It'll resize the grid for you. It'll change the scale automatically. This thing you have to figure out for yourself where to go. But it's super easy, especially if you have a touch screen. You just start playing with the screen until you say, aha, there's one of my X-intercepts. Aha, there's my other. And you can change it however you like. And then again, There's one of them, 36.754, 163.246. So take this number minus that number, and that's the distance between the two arches, which was the problem we were trying to solve. So on Monday, when I actually assign some questions from 4.1, you're going to use this to do your homework. If you do have a graphing calculator and you know you're going to the AP course next year, so it's like, I better get used to this calculator, by all means, try doing some of them with the calculator, and I'll help you with it. All right, that's it for this video.